Namaste everyone. Let's quickly look over things to revise before any test of polynomials, whether it's quarterly, midterm, or actual boards. Before starting polynomials, we should definitely know what polynomial is. Polynomial is made up of two terms. Poly means many and nomial means terms. Basically, it's an algebraic expression of many terms. We represent polynomials by px, where x is the variable we are talking about. Here we will refer to the polynomials having only one variable, and p basically stands for my polynomial. It's just the first alphabet of p, though I can represent polynomials with other alphabets also, like gx, fx, but mostly we take px. If I am representing, if I have two or more polynomials, then I use different alphabets. Also, for a algebraic expression to be polynomial, my power of variable should only be a whole number. By whole number, I want to say 0, 1, 2, 3. It should not be fraction, it should not be roots also. Now let us consider few expressions here. I have named it as px, gx, fx. Though it is not necessary to be polynomial, simply we have given it a name. Let us see whether it is a polynomial or not. It is not a polynomial because if I see this term 5 by x, if I can write 5 by x as 5x minus 1. So here power of x is minus 1, which is not a whole number. So it is not a polynomial. What about here? Here I am seeing root, but root is with coefficient. See, roots with coefficient, fraction with coefficients are allowed, but not with variable. Here if I see the exponent of this x is 2 and this x it's 1, so it is a polynomial. What about here? Here I am seeing 2x minus 1 in roots, but if I square it, if I square both the terms, what will happen? My root will go off, and when I will multiply, I will get something where my x will be having all the exponents which will be whole number only. It won't be fraction, it won't be negative integers also. So yes, it is also a polynomial. What about this? I am not seeing any x over here. Is it a polynomial? Yes, it is a polynomial, though I don't have any variable associated to it, but it is a constant polynomial. What is x raised to power 0? 1, right? So I can definitely associate x raised to power 0 with it, or and it is a polynomial with degree 0. This one also. Here I am seeing that x is having powers as fractions 5 by 2, 3 by 2. But let me simplify it. If I am simplifying it, I know base is same. I can subtract the power 3 by 2 from 5 by 2. So what I am getting, just see. I am getting, this is x square. I am getting x square 5 by 3. 5 minus 3 is 2 by 2, which is 1. So x, finally after simplification, my power of x is just 1. So yes, it is also polynomial, though in first glance it appeared it is not a polynomial. So actually you simplify the things and then only decide whether it is a polynomial or not. Also one more thing, whether it is a polynomial or not, it's not being asked much in boards, but still you should know, you should be prepared for everything which has never come also. These days anyhow in board exams they are asking lot of unexpected things. As I just mentioned a few seconds ago, degree of polynomial. What is degree of polynomial? The highest power of x in full expression is the degree. Like if you see here, x raised to power 100 plus x plus 1. So here highest power of x is 100. So the degree of this full polynomial, let me say it is px, is nothing but 100. Degree is 100 over here. Based on the degree, we can classify polynomials as constant polynomial, linear polynomial, quadratic polynomial, cubic polynomial, and quartic. This is quartic polynomial. We also call it as biquadratic. Biquatic polynomial and biquadratic polynomial is the same thing. Now degree of constant polynomial, as I just discussed, we discussed minus 4 is nothing but 0, x is to power 0. This is a linear polynomial. See, linear polynomial means highest degree will be 1. So I can have one constant which is degree 0 term and one x term. So linear polynomial can have only 2 terms. Same way quadratic can have only 3 terms. One more Then the degree, reason being, we are adding counting 0 also here. Degree 0 term is also there. So 0, 1, 2. Right? And this is the standard notation of quadratic. Same way cubic is degree 3 and quadratic is degree 4. Now let me consider one linear polynomial px equal to 4x plus 1. Here if I substitute x as 1, my px will be 5. X as 2, my px will be 9. This px I can refer as y. We know how to plot x and y terms in a on graph paper. So I can actually do plotting. So I have taken different values of x and corresponding px. I can take x as 0 also, then y is 1. I can plot these values of x and y. I told you this px I can consider as y on graph paper. After plotting, I am getting a straight line. So I have plotted 1, 5, 0, 1, 2, 9. And these are called the values of polynomial. When x is 1, value of polynomial is 5. When x is 2, value of polynomial is 9. So that particular value of x for which polynomial becomes 0, what I mean y becomes 0, is called 0 of the polynomial. So where my y will be 0? Definitely it will be 0 on x-axis. Now here if you see, this is the point where my polynomial, my px is intersecting x-axis. So this particular value of x is the 0 of polynomial because my y is 0. I am repeating my px and y, we are referring them same here on graph. Same way I can plot quadratic, cubic and quartic polynomial. Definitely they are not going to ask plotting for us. But even if they ask, you know how to do it now. And what are the zeros? 0, as we discussed, the point where the graph intersect x-axis. Y-axis because on x-axis only my y is 0. I want that value of x for which y becomes 0. So yes, wherever I am marking from blue, this becomes the 0 of the polynomial. Sometimes they give us graph and they ask us what are the zeros of polynomial. So you can say, you have to simply read the graph, you have to simply see where my graph is intersecting the x-axis. Now, how to get the zeros without plotting? That also let's discuss. We will factorize the expression, the polynomial. I have taken the factorized polynomial only. If I am factorizing, I will have linear factors. Definitely number of linear factors is going to equal to the degree of the polynomial. This is, if I multiply, will be degree 4. This thing will be degree 4. So now I have 4 linear factors. Here if I factorize this, I will have 3 linear factors. And corresponding to each linear factor, I will have 1, 0. Why? Whenever this factor becomes 0, when it will become 0? Let me put x minus 1 equal to 0. Whenever my x is 1, this factor will become 0. And since one of the factor is 0, the whole polynomial will become 0. Same way, corresponding to each factor, I will get 1, 1, 0. X minus 2, I have 0 as 2. X plus 1, 0 as minus 1. X plus 2, 0 as minus 2. So, maximum number of zeros for a polynomial can be equal to degree of the polynomial. This is one of the important things. The maximum number of zeros can be equal to degree of polynomial, and I can have less zeros also. When? If two of my linear factors are same, they will give me same 0. Like here x minus 1, I have twice. So both of them will give me x equal to 1. Here also x plus 2, I have twice. So both of them will give me x equal to minus 2. So number of zeros a degree n polynomial can have is at most n, and it can be less also. Now we have discussed quadratic polynomial in this chapter in very much detail. This is the standard equation. If I say alpha and beta are the roots, are the zeros, zeros or solution, these three are synonyms. Though in polynomials we will be using mostly zeros, they are the same thing. So if alpha and beta are the roots, my factors will be x minus alpha and x minus beta, and definitely if I multiply it I should get the polynomial back. This is the factorized form, the RHS is factorized form, and this is simplified form, the LHS is simplified form. After multiplying the factors, this is what I get. If I compare my LHS and RHS, the coefficient of x is a over here. If I multiply the whole equation with a, after comparing what I am seeing, alpha plus beta is minus b by a, and alpha beta is c by a. And this is nothing but sum of the roots, and this is nothing but product of the roots. So we have developed a relationship between sum of roots and product of roots and the coefficients of quadratic equation. This is the most commonly used relation in this entire chapter. They may ask us to find zeros of polynomial, like in the equation. We have to find roots over here. So what I will do, I will factorize. See, details how to factorize, how to solve the equations, we will do separately. Here I am just doing what and all is required for sure before my polynomial exam. So we have done factorization with my previous knowledge, and corresponding to each factor, my zeros are 2 by root 3 and 2 root 3. So this is the second type. They will give us sum of roots, product of roots, and we have to find the quadratic polynomial. So in this question, sum of roots, which was nothing but alpha plus beta, they have given me as root 2, and product of roots, which is alpha beta, is minus 12. Then they may ask me to verify the relationship between zeros and coefficients. Like in this question. Here they have asked me two questions, if you see. They want us to find the zeros also, because they are saying show that. I can show only if I find the zeros. So after factorizing it, what I will get? Verifying relationship means like I have to show the sum. This is alpha. If I say this is alpha, this is beta. Alpha plus beta is equal to 1 by 2 plus minus 3 by 2, which is nothing but minus 1. Same way here I will do on RHS. We said alpha plus beta is given by minus b by a. What is b here? B is 4 and a is again 4. We know that this is a, coefficient of x square is a, coefficient of x is b, and constant term is c. So c is minus 3 over here. So this is minus 1. Yes, they are true. Alpha beta is 1 by 2 into minus 3 by 2, which is nothing but minus 3 by 4. What is it here? We say it is given by c by a. Yes, minus 3 is c and a is 4. So yes, these two are also equal. So we verified the relationship. This is another set of equation. Here they have told me alpha and the beta are the roots of this equation. So what is alpha plus beta? I know alpha plus beta is minus b by a, which is nothing but minus of minus 4 root 3 by 1. It is given by 4 root 3. What is alpha beta? C by a. So here c by a is 3 by 1. So it is 3. And they are asking me this value. So simply substitute the value. Alpha plus beta is 4 root 3. This is the value of alpha plus beta. And for they have alpha beta, which is 3. We are not discussing how to write the steps and all. We are just discussing the concepts. So this is the answer for this expression. Now this is another set of question. How to do this equation? We never know alpha cube, how to get from this expression beta cube or alpha cube plus beta cube. Yes, we should remember all the identities whatever we have done in 9th grade. We will be using it in upcoming chapters also. We know from here that it is nothing but alpha minus beta cube, alpha plus beta cube, sorry, minus 3 alpha beta, alpha plus beta. These values I have. I know what is sum of root. I know what is product of root. And simply I will substitute. Alpha plus beta is given here by minus of minus 4 by 2, which is nothing but 2. And alpha beta is given by 5 by 2. I will substitute the values here and I will solve for the answer. I am not solving till end. I am assuming I know you are smart enough to get end answer. This is also very important set of question. Here they have given me a quadratic polynomial whose roots are alpha beta, and they want me to find a new quadratic polynomial whose roots are given by 1 by alpha, 1 by beta. So I have to find this expression x square. I know the quadratic polynomial is given by sum of roots these are my new roots, so definitely I have to write 1 by alpha and 1 by beta. X square minus, this is plus 1 by alpha into 1 by beta. Now here I can take LCM, alpha plus beta, alpha beta, x square minus here 1 by alpha beta. I have these values. I know what is alpha plus beta. I know what is alpha beta. Simply substitute the value and get the new quadratic equation. So this type they can give you many expressions. They can give you 2 alpha plus beta, 2 beta plus alpha. So they can give you various new kind of roots where you have to get the value. You have to simply substitute the value, solve it. In end you will get alpha plus beta in expression alpha beta and substitute the values. So this is just one type. They can give you many other kind of new roots involving alpha beta. See, these are few more questions of the type we just discussed. Take a screenshot, try it, and let me know in comment box whether you are getting correct answers or not. Now see this question. This is again very frequently asked questions. So this is my alpha, this is my beta. So what is it? I have seen few students who do, ma'am, this is the equation. So we will put values here. This is after putting x minus alpha, putting the value of alpha beta, we will solve this, ma'am. It's not wrong, conceptually it's correct only, but it will be very lengthy. It will be a 2 marker and you should do it with the shortest method. Rather than doing this, just find alpha plus beta, which is, if I add these two, is 10. What is alpha beta? Don't multiply it. Use the identity a square minus b square. I mean, this is a plus b, this is a plus b, this is a minus b. But multiply it using identity. So after solving, I have got alpha beta as 7. So now what I have to do, simply substitute the values. Where I will substitute the values, I know the equation x square minus alpha plus beta x and alpha beta. Substituting the values, what is the equation? X square minus 10x plus 7, and this is the answer. So now if you see, we are done with mostly all types in this chapter, polynomials, which is generally being asked. But still we should know few expressions how to find. We should know alpha square plus beta square. How to find this expression if they ask. This we can find by identity alpha plus beta whole square. And here if you see, I have done transposition. Generally we write alpha plus beta whole square as alpha square plus beta square plus 2 alpha beta. Right? This is the expression which we know. So I have done transposition. This term plus 2 alpha beta is sent on other side. I know alpha plus beta ka value. I know alpha beta value. Simply substitute the value and get alpha square plus beta square. Alpha cube plus beta cube we have discussed already in one of the questions. Then we should know how to find alpha 4 plus beta 4 also. Now alpha 4 plus beta 4, I will use this expression, this identity twice. So this is the expression, same expression I have used, where I am using x as alpha square, y as beta square. And how to find alpha square, beta square we have done already. This I just showed above. Substitute the values and find alpha 4, beta 4. How to find alpha minus beta? This also we will be doing by identity. Which identity? Alpha minus beta whole square is alpha square plus beta square minus 2 alpha beta. I know how to find alpha square, beta square. I know how to find alpha beta. I will substitute the values and I will do square root of my RHS. So these are the most important things in the chapter which we should revise. For more details, we will be putting more videos subsequently. I hope things are clear to you. This is just a quick revision, so we have not gone in too much of details. If still any doubts, please write in comment box. See you in next video. Bye bye.